Welcome back to Quantitative Reasoning Online, Lesson 14C, Conclusion Observation Studies, Questions. Okay, we should view the video on the interactive tutorial and hopefully go on and do some other investigation on why hair color was not the proper, was the only parameter not really good for building your statistical study on, or your random sampling on. So let's go to question 1 and 2 and see what they have in store for us. Okay, let's see. Describe some characteristics of a good observational study, including how to select a sample, minimize errors, and when to generalize to a larger population. How should a sample be selected? Select all that apply. A sample must be systematic. Samples should be taken using simple random sampling or stratified sampling. The sample must be representative of its population. The sample should be the population in question. Good characteristic of an observational study. Okay. The sample must be systemic. Can we have a systematic sample? Yeah. That's like that doing the every 20th. But the word must kind of turns me off. Because it's saying that's the only way an observational study is by a systematic way. Okay. The sample should be taken using simple random sample or stratified sampling. Should. Okay. The sample should be representative of its population. Yeah, should, representative population. The sample should be the population in question. Okay. So basically, we want to do the entire population, which is, if you can do it, great, but we generally do samples so we don't have to do the population. I'm going with B and C on this guy. Again, notice when I circle a systematic sampling could be used, but it says must. It's one of those absolutes, and absolutes are usually a buzz for maybe, but not the greatest of answers. And again, the last one, because sampling is to not have to do the entire population. Okay, how can error be minimized? Select all that applies. Okay, gather the largest sample that's practical. Okay, larger is better. Okay, so the bigger the sample, the larger sample is, the more chance of being representative of the population. So that's definitely a good one. Sample should be taken using simple random sample or stratified sampling. Okay, that's no way of minimizing error. Minimize the sample space. The sample should be the population in question. And again, the reason we're doing sampling is to not have to do the population. Minimize the sample space. We never even talked about that one, but again, that's literally going for a smaller sample as you can possibly do. So we don't want to minimize A and B. All right. And again, we sample, so we don't need to do the population, and minimize the sample space. We may go too small. Under which cases can a sample be generalized to a larger population? Select all that applies. The sample is the population in question. The sample is representative of the population. Bias is minimized. observations are gathered in ways that do not influence the data. And again, we're trying to do this so we don't have to use the population. Looks like B, C, and D. Alrighty. All the stuff we learned in the tutorials. Next question. That's a lot of it. Notice in each case, that guy was eliminated. Because the whole idea of statistics is to take a sample and use the sample to infer back on the population, on what the population would do. If my sample size is the population, that's not really doing a statistical study. Excuse me. We do want to have representation of the population. We do want to minimize bias. And we do want observations gathered that do not influence the data. Okay, Tedra scores generally follow a normal distribution, aka the bell curve, such that the preponderance of scores fall around the average score. Roughly 68% plus minus 15% of the mean of the average. As you move further towards the extremes of the population of the distribution, scores tend to be less common, thus the curve going down. And we can also look at the area under the curve. The area beneath the curve represents a proportion of the population. 0.2% receive a score of more than 145 and less than 55. In order to interpret the scores are standardized, which involves giving the test to a representative sample. Factors that scientists examine when selecting a representative sample includes, here they are, age, sex, socioeconomic, education, marital status. Okay, there they say it. Cannot find it in the article. And what's missing? What's missing? Hair color. Notice the nicely symmetric graph. Use the graph to estimate the mean IQ score, or the average IQ score. Well, that's going to be where basically the score where half is that way, half is that way, and in between, that was a nice whistle, in between is the mean. And it appears to be 100. So according to the problem statement, very few people score above 145 or below 55. According to the problem statement, which the following is not a characteristic that is generally important when determining a representative sample. We have age there, we have sex, socioeconomics, education, marital status. What's not there? Hair color, finally. And that would appear to be oops. Appear to be it for question 1 and 2 of lesson 14C, conclusions and observational studies, quantitative reasoning online. So with that complete, go in and do it yourself if you haven't already. And then work with Stephanie on the tutorial for the workbook section. And as usual, upload it and then 14C practice. And I'll see you for lesson 15A next.